Okay, so we're back, and we were talking about I, which is the square root of -1, and incidentally, you should get to know these. That means that I squared is -1. That means that I cubed is I times I squared, which is -I, and I to the 4th power is the same as I squared times I squared, which is -1 times -1 is 1. These 4 things you want to memorize because it just keeps repeating itself. What is I to the 5th then? Well, I to the 5th is I times I to the 4th. This is just I times 1. This is just I. Basically, this is like a clock, only instead of repeating itself at 12, it repeats itself at the I place, or depending on where you start. In general, if you want to figure out what is I to the 341st? Here's a great thing. Calculators usually end up screwing this up if the number is big enough. Believe it or not, because they make approximations. I to the anything, do this. It goes around in a circle every 4 times. So do this. We'll divide out by 4, 341. This goes into 34 8 times, 32. We got 21, it goes into 21 5 times, 20 minus 1. So this goes in 85 times with a remainder of 1. Well, so basically, this just spun out 85 times around the clock, and now it's right back where you started with. This is equal to I to the 1. In general, if you have I to the k, do this. Divide k by 4, and you're going to get here something plus the remainder, and it's equal to the remainder. And here's the trick. If the remainder is 3, don't write it as I to the 3rd, write it as -I. Should have seen this in algebra. I may talk a little bit about this more. Well, as far as simplifying things, that's really all you need to know this for. But we have a lot more interesting things going on. But let me remind you of notation and how this looks. So if we have A plus IB, this is a complex number. And here's the complex plane. We call the x-axis the real axis. And we call this the y-I axis. And let me draw it up a little bit. 1, 2, 3, 4. 1, 2, 3, 4. So this is 1, 2, 3. These are our regular real numbers. -1, -2, -3. This is I. This is 2I. This is 3I. Keeps climbing up. This is -I, -2I, -3I. So this is already pretty similar. Where is 1 plus 2I? And incidentally, I just made that number up. You do the same thing you used to. So you go, here's the real, and here's the imaginary. First you go to the real. You go to the x-axis, which is the real axis, R-E, yeah, and we go to 1. Then we go to the y-I axis, and we climb up 2. Here is the point. 1 plus 2i. Here is still the point 0, 0, which is 0 plus 0i, although we usually don't write the 0i. This point 3, this is usually just written as 3, but it is in fact 3 plus 0i. This point, 3i is technically 0 plus 3i. We usually just write it as 3i's. These are conventions. Different instructors will have different expectations with you. It is very standard to, even though this is slightly confusing to people, the number 3, if I say the number 3, is this a real number or is this imaginary number? This is, as it's written, is a real number. This is an imaginary number. How are they really different? Well, imaginary numbers exist in 2 dimensions. the number 3 on the real number line exists, 1, 2, 3, right here. You can graph the number 3 in one dimension. If this is complex, you have to use 2 dimensions, even though it's plus the 0i. This is what you need to graph complex numbers. This is a very subtle point, and it is usually said that real numbers are a subset of complex numbers. And most of my professors at university thought that and felt that way. I studied logic for a long time, and I've never been comfortable with that because you can define all of the subsets of real numbers in first order logic. You can define rationals, integers, things like that, but you cannot define the real numbers from complex numbers in first order logic. This is it's a subtle thing. If any of my old instructors are watching, they're just going to say, he's just never going to get over that. It's not really that much to worry about unless you're really going into the deep stuff, but technically there's a difference between the number 3, the real number 3, and the complex number 3. It's a very subtle thing. Is it going to bother you and perhaps cause you any grief in this class? Certainly not. Certainly not. Okay, so we've got this. Let me show you some basic things about complex numbers. How do you add and subtract them? Well, so what is 5 plus 2i minus, and here I'm going to put parentheses. This is a single number. We'll say minus 1 plus I. Well, here's what you do. Oh, actually, we subtracted. We didn't even go with addition. You take the real parts and deal with the real parts, the imaginary parts. Imaginary parts, deal with the imaginary parts. In this case, this is going to be 5 minus 1. And then I'm going to write it like this, plus, here is 2i minus I. This is going to be, I'll do this. This is 2 minus 1 times I. So this is 6 plus 1i, which I'll just write as I. Okay, so I think that's pretty clear. It got a little messy in there. Basically, the parts, when you're adding and subtracting, you're just dealing with the different parts, okay, and you keep them separate. I'll make up a couple more things and we'll see. What about 5 plus I plus 3 minus 2i? And depending on your book, they'll use notation. They'll probably use some parentheses because these are single numbers, and it's difficult to think about these in terms of not having brackets. I guess I just don't think it's that clear, right? Although in this case perhaps it is. For adding these two complex numbers, it is going to be 5 plus 3 plus 1 minus 2 I. This is going to be 8 minus I, which is, or you could write this as 8 plus negative I. Incidentally, more about notation. Is this one better, or are these the same? Is one better notation? Yeah, these are the same. This is more standard. You'll get used to it, and don't be too worried about it. Okay, so we have to load up some new tape. We'll be back in just a minute.